In this video, I'm going to talk about configurations within SolidWorks and how you can use configurations in the part environment as well as with assemblies to show things on your part in a different state, change properties in different configurations with any given part, and also show alternative positions in assemblies. So here I have a three-dimensional part in SolidWorks. You can see this is made from a single revolve with a single sketch. And then there is two fillet features for the radii at these little lobes right here. The manufacturing drawing for this part is shown here, and you could see that on the drawing there's this dimension A as well as this dimension B, which are driven by what's called a design table. So this design table means that for -04, okay, bad example. For -05, dimension A is 13.4 and dimension B is 1.35. So you can change physical dimensions on your part based on what dash you select. So this is really handy when you have two parts that are nearly identical, but maybe one dimension changes by slightly a little bit. And so you could save papers, save electrons, make a single drawing with a tabulated version of that drawing to show the different versions of this. So how would you set this up in SolidWorks? So this is really handy using the configurations tab. So each configuration is going to be physically a different shape relative to the tab number on my drawing. If I go into here, this third tab over is called the configuration manager. If you select that, you could see that this part is set up with all of the different tabs that are on that manufacturing drawing. And if I right click on a given tab and I say show configuration, you'll see that my part physically updates to reflect the dimensions shown on the tabulated table in the drawing. So let's look at tab 10, double click on that to show that configuration, and you could see that the physical part changed. I could then come in and measure from one end to the other. That measures at 12.2. If I go to my drawing, tab 10, 12.2 is my overall dimension A. So it's really handy to do that. Let's look at how this was created. So you notice at the top of my configuration manager, I have this tables folder. If I open this up, there's a design table. I'm going to open this table in a new window to show you what this looks like and how this part was constructed. So you notice that this worksheet pops up. So this is a Microsoft Excel worksheet, and it says design table for this part number, and we have all of our different tabs. And notice here it says dimension A at sketch 1, dimension B at sketch 1, and then there's a tabulated version of all these dimensions. So where this ties in, this is where you input those dimensions that you want to change with the given configuration name. So how this ties together is if I close my table, go back to my part, and I'm going to go to the sketch that this revolve was created from. If I edit this sketch, I notice that dimension A, if I double click this, every dimension has a name. So if I click on any one of these dimensions here, it says D1 at sketch 1. This dimension is D11 at sketch 1. Well, dimension A is called dim A at sketch 1. So dim A is the name of the dimension, sketch 1 is the sketch that dimension is in. So every dimension on your drawing has a name. And that design table, let's switch back into that. This design table says for each given configuration, I want to change in Drive dimension A, which I just showed you at sketch 1, is going to vary based on which configuration is selected. So if I wanted to add a new configuration, I could say -19. Let's call it new configuration. And I could say that I want this dimension to be 16. I want this dimension to be 2. Now if I click Save and I close this worksheet, a window is going to pop up and tell me that I've just created a new configuration. And now I see here there's new configuration. So if I double click that, I can activate that new configuration and show you exactly what I just made. So So you don't always have to have a design table driving your configurations, but this is a unique tool if you have multiple configurations that you want to add and you want to vary specific dimensions. You could also vary things like color, display states. You can suppress certain features off and on based on which configuration you select. So it's really useful. In the assembly environment, here is a assembly of a hex key set, and you notice that in my configuration manager I have folded and unfolded. So again, configurations can be used to show an alternate position of an assembly. So if I've set this assembly up to where it has these configurations set up. So if I double click unfolded, you notice that all my hex keys pop out, and so I can flip back and forth between the two, showing the hex keys folded and then showing the hex keys unfolded as well. So what these configurations are doing behind the scenes when I suppress this is I've set up this model to where some of my mates are grayed out. That means that they are suppressed. And then when I go to the folded configuration, if I look at my mates, now the angle mates are suppressed and my coincident mates are unsuppressed. So these are activated, these ones are now suppressed. And then when I go over to here and I say unfolded, it's the opposite. So again, configurations are really useful to show an alternate position in an assembly, how something moves if you want to show the progression of the movement of an assembly, as well as different states for your part. One additional example of a part assembly is if I look at this hex key itself, notice that this is a single hex key with a single sweep, and then I have a center axis there. If I go to my configurations, there's all different configurations for this. So again, there's a design table setting this, but if I double click through these configurations, you could see how the model changes. Based on, see, there's a color property. So the metric hex keys come in as a nice salmon color, whereas the ANSI hex keys come in as a beautiful teal. So again, I'm changing properties by selecting different configurations. Let's look into this design table just to see what it looks like. Yep, so you can see, just click OK there. Here you can see there's length at sketch 1, angle at sketch 1, hex diameter at sketch 1. Here's the price per unit, looks like a cost, and you could assign a specific color. So lots of properties can be assigned through these design tables using configurations. In my assembly of the hex key, you notice that in my tree here, there's lots of hex keys. Hex key 4, hex key 5, hex key 6, hex key 7, hex key 8. So there's 8 instances of just the single hex key. And notice up here, this first hex key is an ANSI 3-32, whereas hex key 2 is an ANSI 7-64. Hex key 3 is an ANSI 1-8. So each configuration, if I wanted to change the configuration of this hex key, I could just change this down, and let's put this to a metric 4, just to show you what happens. Click accept, and now that hex key changed its configuration, and it's now in my assembly as a metric hex key there. All right, thank you for watching.